All right, let's go recording. All right, recording has started. All right, good morning, everyone. Today is Thursday, September the 9th. It is 9/9/21. All right, so today we're going to do 1.08 asymptotes and end behavior. This is day one of 2 or 3, I forget. All of you should have 4 quizzes done by now in this class. I think it's 1.02, 1.03, 1.05, and then 1.06 maybe? Something like that, right? All I know is that you should have 4 quizzes done as of today. And don't forget that you get 3 attempts. Never use your 3 attempts until talking to me and kind of figure out why you're missing some questions, right? So, add me on Skype. Best way to do it. You can send me screenshots, snippets of your quiz problems. Dr. J, I went through this maybe once or twice already. I try to go through my ones I missed, but I can't figure out why I'm missing it, right? So send me a snippet, and I will help you through to kind of figure out what you're missing. So that way, when you do your third attempt, hopefully you get a full points, right? All right. So yeah, make sure you have your paper, pencil, pen, graphing tool, Desmos preferably. All right, graphing rational functions. So it says due to rational functions having a denominator, they have 2 distinct characteristics. First one, you're going to have holes in our graph. And the second, you're going to have asymptotes. Now, asymptotes are vertical or horizontal or slants. So they're these invisible lines, whether they're vertical, they're horizontal, or they're slants. They're invisible lines that our graph does not cross over or even touch. So again, asymptotes are just lines, vertical, horizontal, or slant, that your graph will not touch or cross over. They can approach, they just won't ever touch it. And then holes, well, these are just, holes in the graph. And, you may have a nice looking line, but then there's like a little, like at one point, there's nothing. And usually holes are created by dividing by 0. And we'll go through these and how to calculate holes in all these asymptotes. All right, so this picture kind of shows a vertical and a horizontal asymptote. This first one, well, this is a vertical line, right? And this dashed green line here it's not part of the graph. This is just showing that when we graph this rational function, y equals, a fraction, right? Some x stuff divided by some x stuff. I don't know what it is for this one. It creates this graph, and we have holes. Well, not holes, we have asymptotes. And this is the vertical one. So this graph will get really close to this vertical line, but it never touches it. It'll never cross over. Same thing for this part of the graph here. This vertical line, this vertical asymptotes. I call them VA for short. So you'll hear me say VA instead of vertical asymptote. VA and then HA for horizontal asymptote. So this graph will get really close to this VA, but won't touch it. Also want to note that if you've forgotten, vertical lines, those equations are always in the form of x equals some number. Now, because this is at x equals 1, 2, 3, x equals 3 is the equation of that vertical line. So VAs and HAs are always written as an equation, whether it's x equals or y equals. So just a little refresher, vertical lines, x equals some number, in this case, x equals 3. And then for this HA, horizontal lines are always in the form of y equals some number. So in this case, y equals, this looks like -1, -2, -3. So this is y equals -3. That's that HA equation. The same thing with HAs. Your graph will approach it, but it will never cross over. Over here, this graph right here, this part of the graph will approach this HA, this dashed line that I have, but it will never touch or cross over. So, that's a little crash course, little review on vertical and horizontal lines, the equations, and what asymptotes are. Any questions so far before we actually go on to actually do some of the calculations? All right, looks like easy stuff so far. So far, it's painless, right? All right, so for these problems, I have four on the board here. Um, when the denominator is zero, or sorry, yeah, when the denominator is zero, but not also in the numerator. Okay, I need to rewrite this. This sounds like my English is bad, but not also in the numerator. Okay, so to calculate VAs occur when your denominator is equal to zero. And that's because you can't divide by zero, right? Anything divided by zero, well, gives you undefined, right? So that's when VAs occur. You might want to write that in your notes. VAs occur when the denominator equals zero, because you're going to be using this. This is huge. So VAs, it's when your denominator equals zero. So let's calculate this. So with that said, how do we calculate the VA for this first example? We are not doing slants today. In fact, I don't think we do slants in this class. I have to double check. I think we used to do slants in pre-calc. I think it was taken out. If you see it in the modules, please let me know, because I'm pretty sure I took out slants. All right, class, what do you think? How do we find the VA equation for this function? With everything I just said, all my ramblings, what do we do? Ideas. Did anything I say make sense? All right, so Noah says set the denominator equal to zero, and he is correct. Yeah, we're going to set the denominator equal zero because we want to know when it equals zero, and that tells us don't use that value or values, right? Now this one, I need to handwrite everything because I didn't pre-type this stuff. All right, so we have 3x squared minus 6x equals 0. All right, now what do we do? All right, solve for x, everybody. All right, I'm going to give all of you 45 seconds. Ready to go. Now, hopefully, all of you, like I've been telling you, is to go through the modules and work out the examples. So if you've been, faithfully doing the learn and practice modules and working out their examples, even though it's on the screen, like the learn module, they'll kind of guide you through the steps, sorta. They skip a lot of stuff. It's not really that helpful, I guess. But hopefully you've gone through them, done practice, and this should be really easy, right? If you've been practicing Unit 1 so far. All right. Anybody have an answer? So it looks like Noah says x equals 0 and x equals -2. All right. All right, Noah, on mic, would you like to, I guess, take me through this problem, like the steps of what you did? And there's more than one way to solve this equation. Right, take the mic.
Can you hear me?
I sure can.
Okay, so The first thing I did was take out the GCF of x. So that would become, yeah, x times the quantity 3x minus 6.
Okay, hang on 1 second. So you said the GCF. So X is correct. I would agree with you. Can you take anything else out?
Okay. Also 3. You can take 3 out too.
All right. And then what's left over on the inside then?
X minus 2.
Perfect. Now, thank you, Noah. I appreciate it. So if like Noah, when he did this problem, he didn't take out the 3. It's not going to change anything because I'm guessing after this step, well, class and chat, what would you do from this point here to continue solving this problem? Um, yeah, you got to be careful about doing that, Philip. So Philip says divide both sides by 3x. Mathematically, it's not wrong, but you're going to lose one of your answers, and we also don't know if x equals 0, which it actually does. And you can't divide by 0, so you're kind of creating a possible problem. One big problem is you're going to miss one of your answers. So other than dividing by 3x, and mathematically that is something we could do, but when we're solving for x, what's something better? So it's factored, and after we factor a polynomial and we're trying to solve, what should we do? So Noah again says set each factor equal to 0, and he would be correct. So Enzo, you said check the roots. I'm not really sure. You need to expand on what you mean by that. But Noah's right. We set the factors equal to 0. So we're going to have 3x equals 0. We're going to solve that. And then we're going to have x minus 2 equals 0. Yeah, so solve by factoring. And this is something we do, it seems like we're going to do a lot in this class. So once you factor a polynomial, you set the factors equal to 0 and solve. So this is nothing new. We've done this plenty of times, right? And then we solve both of them, right? The first one, 3x equals 0, we divide both sides by 3. We just divide both sides by 3. And then we get x equals, well, 0, right? And then the other one, we're going to add 2 to both sides, right? And then we get x equals positive 2. So your VAs are these two answers. So this tells us that if we were to graph this, and you can, if you want to graph it in Desmos, you can. I'm not going to show this, but the VAs, so we would have two vertical lines. We would have one at x equals 0. That's a vertical line there. And then we would have a vertical line at x equals positive 2. So our graph would not touch or pass those vertical lines. They're like walls. Walls we can't touch or even pass through. All right. So how are we feeling about solving for the VAs? All right. All right. So guys, make sure, you're taking good notes, and I know I keep saying it, you got to practice these problems in the modules. They're required. And I can see how much time down to the second you spend in those modules. All right, everyone, let's do this one. Let's find the VAs for this. Now, if you notice, just real kind of go back to this problem here. This is x squared. So remember, this is let's consider like a second degree polynomial, at least for the bottom portion, right? So we should expect to find at most two solutions, and we do. If you only find one, I'd be a little skeptical because we should find probably two. If that was a cubic, we should find three probably. So this one, x squared, we should find two as well. So let me give all of you, I think 2 minutes should be enough. All right. So we have a volunteer to take us through this problem of what they did. Actually, before we do that, actually, yeah, I'll take the volunteer, but then I want to ask all of you as a whole of how you approach this problem, because there's more than one way. I can think of 3 different ways to approach this problem to solve it. So, class, how did you approach this problem? Anybody? How did you approach this problem? I got 14 people in this class, and it's like crickets. This class isn't too hard for you guys, is it? Or is everyone just too tired to respond? Or you guys, if you're afraid of like getting saying the wrong answer, saying the wrong thing, don't be. Like I really appreciate when all of you guys you give what you think is you're supposed to do, even if you're wrong, because this is an opportunity for all of you to learn from mistakes. So I encourage participation, even if you think you might be wrong. It's okay, because you think about it, I'm a big believer of learning from your mistakes, and you can't learn from them if you don't make them, because if you're too afraid to make them, right? All right, Lalani, you want to go on mic? You want to tell me in chat?
Hello?
Hello.
Oh, hi. Well, for this one, I factored the denominator and then used the factors to find my answer.
And how, excuse me, how did you factor this trinomial?
I looked for factors that would multiply up to negative 12, but would add up to 1. So I found that 4 times negative 3 equals negative 12, but 4 minus 3 equals 1.
Oh, perfect. Yeah, so I called this the simple method of factoring. I don't know what all of you call it. Thank you, Lalani. Appreciate that. And then she said that she set the factors equal to 0, and then she solved. All right, so the VAs, x equals -4 and x equals +3. So who got those two VAs? Who got those two VAs? All right, nicely done. Now, did anybody approach, solving that trinomial, that polynomial differently, but still got the same answer? And if so, what method did you use? So you all did it the same method, huh? So I see. So Noah, you said you used the diamond method. Not sure what it's called mathematically. Could you explain? I never heard of the diamond method. I don't know what that is. Could you explain that to me?
So pretty much the diamond method is the same as the simple method that you called, Dr. J. It's just that it's like can I draw on the board? Is that okay?
Yeah, yeah, go for it.
Oh, okay. So what we learned from like, or at least what I learned from algebra 2 was to draw. I don't know why it's called diamond, but so we draw an X, and so we put A times C on this side and B here and B here. So I did 1 here and -12, and then so that's how I got +4 and -3 because they multiply to -12 and add to 1. So yeah, the diamond method's like the simple method pretty much.
All right, so these need to combine to equal this, and they need to multiply to equal this. Okay, so I see that. Yeah, so this is just a way to organize your thoughts on paper. That's cool. I like that. Yeah, I like that. Yeah, it's a good way to just see it to stay organized to kind of check. So yeah, 4 - 3 is 1, and then 4 times -3 is -12. Okay, I like it. Thank you for sharing. Someone else said that they use the equality properties. So no, I set it to 0 and use the equality properties. What is that? Phil, can you explain? Preferably on mic. Can't do mic. That's okay. It's just adding, subtracting, dividing both sides. So you're talking about from this point you use the equality properties to solve. Is that what you're saying? Okay, I got you. All right. All right. So two VAs. Let's do this one. Yeah, let's 2 minutes. Ready, go. All right. What did all of you get for your VAs? Can it have more than 2 VAs? Well, so good question. So looking at this is a quadratic. This is x squared. So the most you can find is only 2 VAs. Yeah. So this one will only have a maximum of 2 VAs. So it looks like x equals 4 and x equals -1. So, and guys, get in the habit. Remember, these are equations. So, like on your TGA, if you just put 4 and -1, I will mark your answer wrong because you're writing the answer in the wrong form. Remember, this is the form is an equation, and this is a vertical line, so it's x equals. So make sure you get in the habit of doing that. And also, don't put like x equals -1 comma 4, because then you're just listing. So that to me tells me you're just listing 2 x values and you're not listing 2 equations. I know it sounds like I'm being picky, but trying to instill good habits in math. Yeah, so x equals 4 and x equals -1. Very good. All right, what did everyone do for this problem? Let's kind of quickly go through it so we get through the second half of this lesson here. What did everyone do first? You took the GCF of 4 out. Perfect. Yes. So remember, whenever you factor a polynomial, like we're factoring this, right? You always want to check greatest common factor first. That is the first thing we always check. And if you can take a GCF out, you have to. You have to. So we have to pull that 4 out in front. So we get 4 times x squared minus 3x and then minus 4. All right. All right. Then all of us should have factored this using what I call the simple method. 2 numbers that multiply to -4 and add up to -3. Well, I can think of a 4 and a 3. Oops. Just kidding. A 4 and a 1. And looks like the 4 has to be negative. Yep, -4 plus 1 is -3, and -4 times 1 is -4. Then we set the factors equal to 0. Okay, so I understand somebody's question. They asked if there can be more than 2. So we set all factors equal to 0, and that includes that 4. So if you said 4 equals 0, looking at that first one here, can we solve for x in this equation we created? We can't, yeah. So by just having just numbers, 4 equals 0, for one, that's a invalid equation. It's not balanced, right? But you can't solve for x, so we just ignore it. Yeah, we just ignore it. And then we just solve the other 2. Whoops, that's not my pen tool. Yeah, so we get x equals 4 and x equals -1. So the VAs are those 2 equations. All right. So Noah says he graphed it. Right. So this was, I told you a couple slides ago that I could think of 3 different ways to solve that for, this for equal to 0. One of the methods I was thinking of is graphing. So if you took the denominator, which is 4x squared minus 12x minus 16, if you graph this, just the bottom part, wherever it crosses the x-axis, those are your zeros. Those are your solutions. Those are your VAs. So if you graph this, it would cross at x equals 4 and x equals -1. That tells us those are your VAs. So instead of solve by factoring, we could solve by graphing. You mean the denominator, Enzo? Yeah, if we use -1 or 4 in this function, we would get divide by 0, and you can't divide by 0. So those are your asymptotes, and that's why we're setting the bottom equal to 0, and we're solving, which I should have actually written equals 0 just for completeness, right? So we set the bottom equal to 0, and we solve. And we could solve this by graphing it. Graphing it would yield us the same answers. Now, if you graph this entire function, it wouldn't tell us where the zeros are. It would just have the invisible vertical lines. But if you graph the bottom portion, wherever it crosses the x-axis, which in this case it would cross at 4 and -1, that tells us those are your VAs. If we use +1, we would not get divide by 0. So yeah, check your math. So yeah, so 1 squared is 1. 4 times 1 is 4. So there's a 4 right here. -12 times 1 is -12. So we have 4 minus 12 is -8. And then -8 minus 16 is what? -24. It's not 0. Yeah, -1 is invalid. That's why it's here. Yeah, see the VA is -1. This tells us these are where your asymptotes are. So yeah, -1 and 4 are invalid. Going back to this problem, -4 and 3 are invalid because we would divide by 0. And then for this first one, 0 and 2 are invalid because it would make us divide by 0 in the original function. Yeah, please do, because I'm missing what you're saying.
So I'm just confused because this sentence up here, under vertical asymptotes, says that it's only an asymptote if it doesn't also make the numerator 0. Is that what you're saying?
Yeah, my English is not so good when I wrote this. So yeah, so when the denominator is 0, and that's what we were doing. So the VAs are when the denominator is 0, but not the numerator. So we don't set the numerator equal to 0. That's what I meant. But yeah, this doesn't make a whole lot of sense. I need to rewrite this. Yeah. Okay. Yeah. So remember, VAs is just setting the bottom, the denominator equal to 0, and solving. And those are the vertical asymptotes. The going back to the picture, this is a VA, a vertical asymptote. All right. I'm going to skip number 4. But the VA for this one looks like it's, well, let's quickly do it real fast. 30 seconds. Ready to go. 30 seconds. Ready to go. Yeah, this one's super, super easy. All right, everyone, what did you get? What's the VA? X equals what? X equals -1. Yep. Yeah, that one was super easy. If you're wondering how we got that, you need to actually do the work on your paper. And if you can't get that answer, we need to talk. All right. HAs, this is the second half. We have like 20 minutes, so I think we did 20 minutes. All right, HAs, these are horizontal lines. where the function does not exist. So not all rational functions have horizontal asymptotes. That's important. So with VAs, if you have a rational function, rational means just a fraction, right? If you have your y equals a fraction with x's in the bottom, we're always going to have a VA. But just because we have a rational function doesn't mean we're going to have an HA. So we may not have HAs, but we can still have VAs. All right. So the form, like we talked about before, HAs are written in the form of y equals some number. I'm just going to put like some number, right? Yeah, y equals some number because they're horizontal lines. Talking about range, we will kind of. I'll mention range. We're going to do range this unit, but I'm pretty sure I do it in a different lesson. But I will talk about range. So we know about domain and range already from past classes. Domain is all your x values, your valid x values. Range is all of your valid y values. So we're definitely gonna talk about this. Probably not today in depth, but I may, if we have time, kind of go back and write domain and range for all of them. All right. So we have 3 scenarios. All right. So we have, when calculating HAs, we have it when our function is top heavy. We have it when our function is even, and when our function is bottom heavy. So let's kind of go back and explain what top heavy, even, and bottom heavy mean. So top heavy, you're going to look at your function, and you're going to look at your highest exponent on the variable. So in this case, it's x to the 4th on top, and on the bottom, it's x to the 3rd. And we can all see that the 4 is greater than the 3. So this is considered a top-heavy rational function. Looking at this one here, this is x squared, and this is just x to the 1st. So, the 2 is greater than the 1. So this would be considered also a top-heavy rational function. Right. Does everyone follow of what it means to be a top-heavy rational function? All right, good. All right, so whenever it is top heavy, we have no HAs. So when it's top heavy, your HAs, like on your TGA, you'll have to answer one of these questions on a TGA. Your HA, just so I know that you know, well, none. Yeah, so there's no HA for this one because it's top heavy. Again, if your function is top heavy, there is no HA. So this is the scenario when we don't have any horizontal asymptotes. But by the look of it, you can see that we will have up to 3 VAs. In this one, we're going to have just 1 VA. But we're just talking about HAs right now. All right, top heavy, HAs none. So you might want to write that down. Top heavy, no HAs. So put that in your notes. All right, even. When it's even, so if you look at this, this is x to the 3rd, and this is x to the 3rd. So these are the same. So this would be considered an even rational function. And this right here, this is x squared. This is x squared. So again, they are the same. So this would be considered an even rational function. Now, the ones that are even require the most math to calculate. But the math is super easy. All we're going to do is we're going to take the coefficients. So we would take the 1 that's in front of this x cubed, and we would take the 6 that's in front of this x cubed, and we go, well, 1 over 6. So your HA for this first one here, your HA, remember it's always y equals, is going to be the leading coefficient, which is a 1, over the leading coefficient on the bottom, which is a 6. And then you would reduce it if you can. But we can't. 1 over 6 is already reduced. So there's your answer for, well, that first example. All right. All right, everyone, looking at the second example, what is the HA? Y equals what? Yeah, -1/2. Yep. So the HA for this one is going to be y equal, that's a -1 over a 2. So that would be your HA for that one. And so going back to putting that, so I personally like having the negative in the numerator. Whenever I do a fraction, I always keep the negative in the numerator. I like the way it looks. But your modules, on your quizzes, on your exams, on your midterm, on your final, they want you to put the negative out in front of the fraction. So they want you to write it like that when you submit your answer, because it doesn't know the difference. It doesn't give you credit if you put the negative on top, even though it should. So with that said, if you do what I do and you put the negative in the numerator and it marks it wrong, and when you go to review what you missed and you see that, message me so I can change your grade manually. It's a pain, so preferably you remember to put out in front, but if you forget because it's habit like me, and you do that, just message me. I'll fix it for you. All right, so that's HA. So HA is the hardest one because we have to do some math, right? The next one, bottom heavy, super easy. So when it's bottom heavy, so like you see here, this is x squared, and this is x to the third. So 3 is more than the 2, so this is considered a bottom heavy rational function. This is x squared, this is x cubed. 3 is bigger than a 2, so it's bottom heavy. Whenever it's bottom heavy, the HA is always y equals 0, always. So we say, well, the HA is y equals 0. And then for this one also, this is bottom heavy, y equals 0. How easy is that, right? Yeah. HAs are super easy to calculate. So going back to just kind of recap everything, top heavy, there's no HAs. Even, you take the ratio of the coefficients. Bottom heavy, it's always y equals 0. So again, top heavy, none HAs. Even, you take the ratio. Bottom heavy, it's always y equals 0. As long as you got those written down, you memorize those, is this cake. So believe it or not, on your TGA, on your test, people miss HAs. Really, honestly, HAs are kind of freebies. And hopefully you agree with me. HAs are freebies. They're super easy. But people who don't come to live lesson, they don't practice those module examples, whether it's learn or practice, they miss easy problems. And really, those people, if you ever listen to this recording, I hope you do. If you're not going to put the work in to this class to learn it, you shouldn't be in this class. Remember, this is not a required class. You could take an easier math class if you don't plan on going to a university right after high school. So pre-calc is not easy. I can tell you that. If you just barely didn't work to get past your Algebra 2, Algebra 1 geometry class, you do the same thing in this class, you will not pass it. I can pretty much promise you that. Because all of you have pretty much discovered by now that this class kind of takes everything one further step. We are applying different concepts into new concepts. So, Algebra 1, Algebra 2, you just had to, you're given an equation and it says, all right, factor it. And then all we do is how to factor it. Well, this one, I say find the VA. You have to know, set the bottom equal to 0. We then have to know, okay, I need to factor this, and then, proceed accordingly. So, this class kind of incorporates a lot of different concepts and different problems. But yeah, so anyways, went off on a tangent of, being good students, guys. Practice. Ask for help when you need it. Don't fall behind. Don't struggle your way through concepts. If you're somebody who just doesn't want to ask for help, I feel like it's like me when I'm out and my girlfriend's always telling me, like, if we're lost, which we're never lost, right? I never get lost. Sarcasm. And I don't want to ask me for directions. Like, no, I'm going to figure it out. I gotta I got my phone, I got my GPS. I'll figure it out. I don't need help. So don't be like me. If you're struggling and you feel like you're falling behind, you need to ask me for help. I don't know if you're struggling if you don't say anything, right? All right. These four. All right, we got about 11 minutes. So, everyone, I'm going to give all of you, I think, really 2 minutes for HAs is, I think, enough. So let's do a 2-minute timer for finding the HAs for all four of these problems. And these are the last four of the day. So once you find the HAs, I'm going to ask you, is it A, B, or C? So, identify, is it top heavy, even, or bottom heavy? And then after, we all answer A, B, or C for all of these, I'm going to ask all of you, what is the HA? So 2 things, right? So make sure you identify both things. All right, everyone. Oops. Hopefully that was enough time. So for number 5, you put A, B, or C. Number 5. All right, everyone got it right. Nice. So yeah, it is B. This is considered an even. All right. So in chat, you said it was B. What is the HA then? So make sure you reduce. So I want the reduced answer. So y equals 2. Y equals 2. All right, nice job. Yep, y equals 2. So this brings me to another point. So, your setup, right? Your setup for this was y equals 2 over 1. And then we reduce that and we get 2. On your TGA, if you write y equals 2 over 1 as your answer, I will mark that wrong. And here's the reason. And because you didn't finish the problem. You didn't finish the problem, I can't give you points. So if you do not reduce, you do not simplify where appropriate, like in this case, you put y equals 2 over 1, I will mark that problem wrong because you should know you need to simplify, right? I know my grading is harsh, but you will learn. All right, number 6. Is it A, B, or C? All right. Number 6 is also B. It is also even. And what is that, HA? So y equals -1/3. Yep, I would agree with you. So people who put the negative in your denominator, I am honestly tempted to mark it wrong. I won't, but I want to say it's a rule, but I don't think it's a rule. It should be a rule if it's not. I feel like we shouldn't have negatives in our denominator if we can avoid it. Did any of you learn that as a rule in past classes? I haven't taught those classes in so long, so I don't remember if that is a rule or not. I don't think it's a rule. So you learned it as a principle? Yeah, I think I would agree with Enzo. It's more of a principle. Yeah, we should never put negatives in our denominators. Putting it out in front or putting it in the numerator is good. It's okay. Putting it in the bottom, at least I learned way back when that it was a no-no, but it's not wrong. So if you left that negative in your denominator, I wouldn't mark it wrong. I might like cringe a little bit, but that's it. And I might like do like an arrow to it on when I grade, and I put like a little sad face. So guys, when I grade your TGAs, I put lots of notes. Like I actually read your work and I comment on a lot of your math. So whenever you get like a grade, especially if it's like not full points, remember you're allowed 2 submissions, by the way, for your TGAs. Your first submission, I'll put notes. I'll give you a lot of like pointers, like look at this. What you do here. You might want to do this instead or whatever. So yeah, make sure you read my notes when I grade TGAs. All right, number 7. What did all of you put? Number 7. Hold on, I'm going to re-poll because I have one person that didn't select the right answer, and all right, I'm going to re-ask this polling question. So, what did you put for number 7? I'm hoping it was just a misclick. Okay, yeah, it was a misclick. All right, yeah, we're good. Everyone chose A. A is correct. All right, A. So, and then what? So this one is considered top heavy. So what is the HA, everyone? Yeah. So don't put Y equals none. You would put HA is none. Yeah. Yeah. Don't put Y equals none. Yeah. Don't put Y equals none. You say HA is none. Y equals none just looks kind of weird. I wouldn't mark it wrong on a TGA, but yeah. Yeah, just none. All right. What did everyone put for the number 8? What is that one considered? All right. All right. Yep. It is considered bottom heavy. Looks like I keep saying it, but some of you just come to class and you just like you bail. I don't get it. Ooh, some of you chose B and D. Are those people just like they misclicked? Yeah, this one looks like one person chose B, one person chose D. I'm going to sum that up to a misclick, or maybe they were tabbed out when they came back in and selected it by accident. So yeah, this one is definitely bottom heavy. Yeah, it's, there's an X to the first on top, there's an X squared on the bottom. Remember, we're looking at the exponent, not the coefficient. So that's an X to the first, on the bottom is an X squared. So that is bottom heavy. All right, class, what is the HA for that one? Yeah, Y equals 0. So one thing I do want to point out is it is a common mistake, because Unit 1 is super long, which you probably noticed, and there's a lot of stuff to remember. So, when we learn this today, if you don't practice, you don't review, you may accidentally on a quiz or a test look at a problem like this and see that 3 and then compare this 3 to that 2, and you might say it's top heavy by mistake because it slipped your mind that we are comparing the exponents. So, when determining if a rational function is considered like a top heavy, even, or bottom heavy, you're looking at the exponents. 1 versus 2. 2 is definitely bigger than 1, so it's just bottom heavy. All right, everyone. How's everyone feeling about calculating VAs and HAs? Super good, it looks like. That's good to hear. That is good to hear. All right, everyone. Well, thanks for coming. And as always, I hope you learned something. I will see you all tomorrow. Tomorrow's Friday, so happy early Friday, right? All right, take care, everyone.